Hey guys, quick video tutorial about the new Bionoi, however you say that, absorbance 96 wall reader. This is the unit here. There's only one connection in the back. There's no power switch. It's all automated. There's an eject button over here that we'll use in a second. And the software is installed on this laptop. Once it comes up, the code is here to get in. It's a little slow, even though it's brand new, so be patient. There's a pretty picture of a sunset if you need something to look at. Okay. So here is a folder called Enzo Plate Reader that has inside of it the user's manual, instructions for use 1.4, and in there's directions on how to set up quantitative and qualitative schemes. I'm not familiar with any of that yet. I just turned it on and took some absorbance or OD measurements, and I'll walk you through how to do that. The more advanced features are in here. Okay, so if you go to the start menu and click here, Absorbance 96 app with this little B as an icon, it will open the software. It's pretty intuitive to use. It's a little bit fumbly in terms of setting up the samples when you do it at first, but it becomes better with time. Okay, so one thing you need to do is name your assay here. I'm just going to put CDS, and then you can give it whatever descriptions you want there in the top. And then down here, this is where you choose your wavelength. So if you're doing OD 600, you want to use the 620 nanometer wavelength here. That's best for bacteria. Okay, so you have a sample wavelength. And if you want to use a more advanced feature, you can use a reference wavelength. And that's part of the quantification if you have calibration standards and such. If you just want to take a quick measurement, I would just leave the reference measurement as none. I'm interested in these carbon nanoparticles that function at a wavelength absorbance closer to 405. It's actually about 390, but this is close enough. Same thing for your OD 600. 620 is not exactly 600. You just need to report in your methods that use 620 and not 600, and it's usually close enough for these types of spectra. If you go through the user's manual, you can find out how to do kinetic measurements over time if that's something interesting to you. Endpoint simply means it's going to turn on the LED, read the signal from the photodiode on the backside of the well, and just give you a discrete number in terms of absorbance. Evaluation here, I'm going to set up no evaluation, meaning it's going to give me raw absorbance data. You can do a quantitative or a qualitative, and if you do that, you can see that as soon as you do quantitative, it'll ask you for all sorts of fitting methods, linear, 4PL, 5PL regression, so linear or nonlinear, and it has two different types of nonlinear, 4 and 5PL. And you can have predefined standard curves in some cases. If you do qualitative, the manual can walk you through this calculation for a qualitative output. I'm not interested in letting computers do my analysis, so I always record raw data using no evaluation, and then if I'm using a calibration, I just make my own. Okay, so down here, we see if you leave all of those settings, I'm going to go back and walk you through them. There's title. If you set it on 405 with no reference in my test, I'm going to do endpoint and no evaluation. Then I'm ready to go down here. So what I do is I click sample here and name my sample. Okay, so my first sample is tonic water or quinine. Okay, so over here I have, notice that 1 is highlighted with this blue ring, and I have a name there. So also this duplication pattern is something that you want to be careful with. So in my well here, I have column 1 has 8 discrete wells in it. So unfortunately there's no way that I found to select all 8. So what it's asking you in this duplication pattern is what kind of sequence are you going to do. You can do them one by one. I'm going to do it 1 by 4 like this. So that means that when I click here on A and drag down, it's going to put a 1 by 4, and it's going to identify it with this number 1, which is identified by what I put over here, in my case canine. In my wells, I actually have a whole column, so if I drag that again, then I have a 1 by 4 and a 1 by 4, but notice that they all have 1s. So this is sample type 1. So now I'm going to add, in my plate, in column 2, I have a 1 by 2 pattern here. Just, that's what I randomly chose arbitrarily when I was setting up this quick example. And those samples are what I'm going to call CDS. And when I drag that, oops, sorry. See, I accidentally did that where this was still highlighted as 1. So what I can do is I can just click clear, and then I can go in and just individually select what I made a mistake on with this clear button. Go back to sample. What I didn't do was push 2 here. So you have to highlight it here, and now what I drag, or what is this? Okay. Be ready for a crappy computer and lots of weird hackers getting into it or whatever they're doing. Canine is my row 1. Here you can see that identified by 1, and 2 is my CDS samples here. In my plate, I have a 3rd column, and just to learn how to use the system, I'll call it blink because this is just water. Just how to learn how to use the system and play with it a little bit. I put it over here. Whoops. And it's still on 1 to 2. What that means is every time I do a drag like that, it's only going to give me 2. So that's a little bit of a weird feature that you have to play with in laying out your plate. You can do 1 by 1. There's probably a better way to do it than what I'm doing, but what I'm showing you works. So I lay out my plate. I have sample 3 is blank, sample 2 is CDS, sample 1 is canine. Remember, this is 405 with no reference. And now I just click readout, and it reminds you, please ensure that the slot is empty for initialization. And it means this slot. So check that there's no plates there and make sure that's okay. And then push OK. And what it's going to do is it's going to test the 405 LED. If you're doing 620, it will test the 620. If you're doing multiple, it will test the multiple LEDs. Okay, now it says, please insert microplate into slot. Ensure that the arrow on the underside of the slot is completely visible. Make sure that your A1 is in the top left corner. That's how we laid out the map in the previous. So with that in place, make sure you're reading this text in this format, and you can see a reminder here. Make sure that your plate, just gently push it in. Be very careful not to be too rough with it because there's not a good spill system here to take care of spills. And if you spill inside of that and get a bunch of water, then it's going to fry the system. Okay, so come over here and push OK. And now it's reading. Takes 30 seconds maybe. In this case, all I asked it to do is give me raw absorbance. So I see canine should not fluoresce at 405 or give any absorbance, rather. This is not fluorescence, sorry about that. So it should give me a 0 signal, and you can see that it does. On the right, this is water. So this should give me a 0 signal, and it does. My carbon dots this A2 is my concentrated sample. B2 was a very, very rough half dilution done with kitchen utensils. So this is not accurately half, but it's close. You can see that this is approximately half the signal, and that's close enough for what I was doing in this test. Okay, so very quick results. And now if I want to save the method, I can do that. If I want to export save the method over here on the left, that will save it as a BYOB file, and you can just reopen that file and reuse it for the same plate design and same everything. In my case, I don't really care about saving this method, whoops, but I do want to export. There's this weird thing on this computer where it opens this really big window and you can't see the export button, so you have to resize for some weird reason the window. Sorry if my video wasn't good. What I did is I dragged here. I just resized the window because when it's full, let me zoom out and pay attention to my video. So when it's full, sometimes this export doesn't show up, which is kind of weird. So if you push this little minimize button, it can work better. Sometimes for some reason I have to manually drag the window. I have no idea why. This laptop is not exactly state of the art. So if I push export here, I recommend doing CSV. Just click that button, then it will pop up. Then export as a CSV file, which you can open in Excel, and it will delimit your data all in Excel format. Let's just show you an example. So yesterday I did that. This is the CSV file. Opening it in Excel now. I recommend not trying to do any data analysis on this computer. It's new, as I mentioned, but it's very slow and very clunky. So I would just put your files on a USB and analyze offline on your own computer. That's more useful. So the CSV file will open, and as you can see, it has the layout here. I still don't know how to have it tell you exactly what your samples are here, but there's a way to do that. It does tell me what the reading and the reference were down here. So as long as you keep track of what you're doing, notice that I didn't analyze these wells, right? So rows 3 through 11, and also these rows here, but it still gave me this data. So be careful to pay attention to your plate readout and only take the wells that you need, because it is exporting data here, which is all basically zeros. That's it. Hope that helps.